Hi, so this is review on sequence and series. Um, in the NET exam, part A, um, they do ask questions on sequence and series, but not in a fashion where it is directly linked to the formulas. Yeah. Um, Although I did come across a geometric mean question, so I'll quickly discuss arithmetic mean, geometric mean, and geometric progression, or arithmetic progression, sorry. Arithmetic progression, geometric progression, and then geometric mean. It will be, I think, two two videos at the most on this topic. Yeah, let's begin. Okay, so we'll first discuss arithmetic progression, AP, in short, AP. So whenever there's a constant difference between any two successive terms, then the sequence is said to be in AP. So what is the difference in this sequence, in this series? The difference is positive 2. And in this one, it is negative 2. So let's say I want to find the fifth term for the first sequence. And let's call this a second example, okay? So for sequence 1, find the fifth term, okay? So usually we don't have to apply the formulas which I'm going to discuss right now. We can simply say, okay, 2, 4, 6, 8, these are the four terms. The fifth term is going to be 10. So we get an answer. No need to apply the formula, but I'm just showing you, um, you know, uh, the formulas. I'm just giving out the formulas and how to apply them. Just in case if you have something going on as to finding out the 100th term or the 50th term, something like that. Okay. So in AP, nth term is equal to A plus n minus 1 times the difference. So if I want to find out the fifth term, that is n is equal to 5, A is the first term, A is the first term, and that is 2, and then 5 minus 1 into the difference, that is the difference. Okay. So it is positive 2. So 2 plus 4 into 2 is 8, which is 10. So we already know that the fifth term is 10. And for sequence 2, find the fifth term. So we know that the fifth term will be 0 because the difference is negative 2. So therefore the nth term formula, the fifth term for sequence 2, now the first term is 8, and then 5 minus 1 into negative 2. So you got 8, and 4 into negative 2 is negative 8, and therefore you get 0. Understood? That's your fifth term. So that's the summation, that's the nth term formula. So remember the nth term formula. A is the first term, and D is the difference, and N is the nth term. Okay, moving on. So let's say I want to discuss summation of a sequence. A sequence which is in arithmetic progression. Okay. So sequence AP summation formula. So let's say the sequence is 2, 4, 6, 8. Yeah. dot dot dot, and you want to find the sum of the first five terms in sequence 1. So the summation formula is um, first term plus the last term divide by 2. Yeah, that's basically taking the average into the number of terms n. So for example, let's say the first five terms out here are 2, 4, 6, 8, and 10. Okay. Now, if you see the first term and the last term, yeah, if we divide it by 2, that is first plus last, 12 divided by 2 is 6. And whenever the sequence is in AP, the middlemost term, or the first and last, or the second and second last, divide by 2 always give you the mean. Okay. And then into the number of terms. So out here, the first term is 2, last term is 10, divide by 2, that is 6, into the number of terms. 6, 5 are 30. So that is what we get. 6 and 4, 10. 2 and 8, 10, and then 10, so 30. Okay. So that's for the arithmetic progression. Remember the nth term formula is a plus n minus 1 into the difference, and the sum formula is first term plus the last term divided by 2 into the number of terms. Now, in the textbook, they don't usually give you this as a formula. They give you this as a formula. They'll give you a, and the last term is the nth term. So you'll have a plus n minus 1, the whole thing into the difference. Yeah. Okay. And then you have divide by 2, the whole thing into the number of terms. So you'll have a formula like this, where obviously you simplify it further. So you have 2a plus n minus 1 d, and then divide by 2. So you end up getting a plus n minus 1 d over 2. Yeah. Hmm. You get a formula like this for the sum. Okay. I'm just double checking my work. Yeah, I think I forgot the n part. Yeah. So then it'll become a plus n minus 1 d by 2, and then it'll be into the whole thing into n. Yeah. So that is most probably the textbook example, or the this part is not required. Yeah, it's just this on its own, like this, into n. Okay, so that's the answer. No need to simplify it. So remember basically these two formulas. Yeah, moving on. Geometric progression. But before that, we'll quickly discuss geometric mean. So let's say you have a sequence of numbers 2, 4, yeah, and let's say 6. Okay, 2, 4, 6. So what will be the geometric mean of this? So what we do is we multiply it, okay, and then we take the third root of it. So if it was only 2 and 4, yeah, then the geometric mean of this 2 and 4 would be 2 into 4, and then we take the second root of it, or meaning square root of it. This is cube root, square root, yeah. And suppose there were 8 terms, 2, 4, 6, 8, 10, 12, 14, 16, like that. Then you multiply all of them, 2 into 4 into 6 into 8 into 10 into 12 into 14 into 16. So there are 8 terms, and then you take the eighth root of it, like this. That'll be your geometric mean, GM. Got it? That's that's about it. It's just the way things are calculated. It's more of a stats thing. Yeah. So there was one question based on this in the December NET 2024. That's why I'm discussing this. Okay. Now, final thing, we move on to the geometric progression. So remember, the arithmetic progression was there's a constant difference between any two terms. In geometric progression, there's a constant ratio between any two successive terms. And in short, we call it GP. GP. So let's say you got 2, 4, 8, 16, like that. So if you see, there's a multiplier 2. So every other term I get by multiplying 2 to it, like 2 to the 4, 4 to the 8, 8 to the 16, and so on. So there's no constant difference. There's a constant ratio, or you can say a constant multiplier between any two successive terms. So clearly in this sequence, yeah, the ratio is 2. Now suppose if it was like this, 32, 16, 8, 4, and so on, then out here the ratio would be half, because there's a constant multiplier of half. When I multiply 32 by half, I get 16. If I multiply 16 by half, I get 8. So the ratio out here is half. Okay. So for this, the nth term formula is a into r raised to n minus 1, where a is the first term, r is the ratio, and n is the nth term. So for example, find the fifth term of sequence 1. So we already know the fifth term is 32. So we'll just use the formula. Yeah. So the fifth term, n is 5, a is the first term, ratio is 2 raised to 5 minus 1. So that is 2 into 2 raised to 4, which is 2 into 16, 32. And similarly, for the find the fifth term of sequence 2. So again, the fifth term is, the first term is 32, a. So that's the formula we're using, into the ratio half raised to 5 minus 1. So that is 32 into half raised to 4. Okay. So what is half raised to 4? 1 raised to 4 is 1. 2 raised to 4 is 16. That's 32 by 16, which is 2. And we already know our fifth term is 2. We know that 32, 16, 8, 4, and 2. So uh, as far as possible, do not complicate things. Do not, just because you know your formulas, do not try and forcefully apply it in any question. First, try and do it logically. Okay. Like you can clearly see 32, 16, 8, 4, the fifth term is 2. Yeah. No need to apply the formula. Okay. Right. Now we'll move on to the summation formula for geometric progression. There are a few things that you need to remember in the summation one. Okay. So the sum formula, sum for a GP, geometric progression. So the sum is A, the first term, and there'll be a ratio 1 minus R, yeah, upon 1 minus R raised to N, yeah, like this. Okay. 1 minus R upon 1 minus R raised to N. Okay. I'm not sure about the formula. I'll just double check by actually using a sequence. So the sequence we'll take is 2, 4, 8, 16, dot, dot, dot. So find the sum of the first four terms of sequence 1. Okay. So we can already calculate it on our fingertips. 16 and 4 is 20, 28 and 2 is 30. Yeah. So we know the sequence 1 has a sum of 30, but we are just trying to apply this sum formula. Yeah. Where A is the first term, R is the ratio. The ratio is 2 out here upon 1 minus 2 raised to and 2 raised to 4 because we are taking first four terms. So 2 into minus 1 upon 1 minus 16, 2 raised to 4 is 16. So that's 2 into minus 1 upon minus 15. Yeah. So yes, there was an error. So the error is that I cannot take this. I have to take 1 minus r raised to n. Okay. So it is 1 minus r raised to n upon 1 minus r. Correct. Okay. Yeah. So it is the other way around. Okay. So I'll just go retract it back. So, hmm. So I'll write down 1 minus 16 minus minus makes it positive. So you got 30. Yeah. Now let's take the second sequence. So second sequence, we'll take it as 32, 16, 8, 4, dot, dot, dot. So find the sum of the first four terms of sequence 2. So the sum is A into 1 minus r raised to n upon 1 minus r. First term is 32. Ratio is this time half, remember, raised to 4 upon 1 minus r. So that's 32, and it is 1 minus 1 by 16 upon 1 minus half, which is half. Okay. Huh. So then what we have is 32 and then 15 by 16 upon half. So that's 32 and 30 by 16 if I'm not wrong. Yeah. And then this 16 goes with 32 two times and I've got a 60 as a sum, and you can see the sum is 60 That is 8 and 32 is 40, 16 and 4 is 20. So it just makes sense. That's the right formula. Okay. Yeah, right. So now within the geometric progression, there's a concept for converge, converging sequence, or you can say a sequence that has a ratio between -1 and 1. So when there's a ratio between -1 and 1, in geometric progression, if the ratio is between -1 and 1, then the sum formula reduces to a upon 1 minus r. How? So the sum formula is a into 1 minus r raised to n upon 1 minus r. And then, yes, uh, in geometric progression, the ratios between -1 and 1, yeah, and if the sequence is infinite, and if the sequence is infinite, then the formula reduces to a upon 1 minus r. So how? So now sum for an infinite sequence, provided the ratios between -1 and 1. So when there's an infinite sequence, this a into 1 minus, now remember, if the ratio is between -1 and 1, it's a fraction. So any fraction raised to n becomes negligible. Yeah. So here r raised to n is negligible. Negligible. Therefore, it becomes a upon 1 minus r. And you can take an example sequence. I'll put 3 out here if you like. Let's consider 32, 16, half, 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 yeah, 1, and so infinite sequence. So when there's an infinite sequence and we have to find out the sum, it is a upon 1 minus r, yeah, sum of infinite sequence. So a is the first term, 1 minus the ratio, which is half. So it's 32 upon half, which is 64. So that is my answer for this sequence if it's infinite. So the idea is very simple, that 32 and the remaining right up to the infinity, yeah, it almost goes up to 32 but never really touches 32. So you'll get 31.99999 for all the terms starting 16 up to infinity. That's the idea. So that's it about the formula part, and now we'll solve this handout sequence and series. So I'll take it in the next video. Yeah, I'll take it in the next video. That's it. Thank you.